Okay, everyone. We are going to pick up the next section. I have some, I guess, good news, bad news, depends on how you look at it. We're going to go for 45 minutes today, and then we're going to stop class. So that'll put us at what, around 1:15, somewhere around there? 1:45. Yes. I've got to cut out and be somewhere at 1:30, so I've got to end a little early. Pardon me? No, I'll remember. I'm just letting you know. I mean, but if I forget, yeah, of course. So what I'm gonna do is I'm gonna get right into the material, and I should be able to finish everything that I did in my other class. In my other class, we kind of took a couple of probably first 15 minutes answering questions on homework. So did anyone have questions on homework by chance? Is that the last one? Okay. What I will do is if you go to our website or go to Canvas, and are you okay getting onto the YouTube videos? It's on the other class. Today's lecture, I did number 43, the last one, and I also did number, oh no, 27. We were going to do it. We didn't do it. So I did number 43 on that class if you want to look at it, okay? Okay, we are going to start 5.4 today. What we did last time is we talked about adding and subtracting. Polynomials. And the idea behind adding and subtracting polynomials is that you had to have this thing called like terms. And then if you had like terms, all you did was do what? So like if I have two like terms and I want to add them, what do you actually have to add? The number in front. It's called the coefficient, right? You just add up the numbers in front. But you don't change the variables, right? You didn't change the x's or y's or z's. Today, we're going to move on to the next operation, which is going to be multiplying. Now, when you multiply, things do change with the variables. So let me ask you to remember a very important property of exponents. It said, if I have x to a power times x to another power, so if we have the same bases, xx, we have different powers, we would rewrite this as x, and what would we do with those powers? Add them up. Okay? Add them up. Right? Okay, we need that today. So what we're going to do is start multiplying polynomials together. I also want to remind you that we had some words, some definitions. If we had more, like if we had one term, we called it something, two terms, we called it something, three terms. So let me remind you what that was. If I just write 4xy, how many terms is 4xy? Just one term, right? That's a single term. We call single terms monomials. Mono meaning one, okay? So if you have a single term, 4xy, it's a monomial. Now, if I write 4xy plus 2z, now I have two terms, right? The 4xy is one term, 2z is another term. There's addition between the two terms. So we have two, right? We call that a binomial. Bi meaning two. And the last type of thing we're going to look at today is what would be called three terms together, trinomial. Right? We have three terms here. 1, 2, 3, separated by first subtraction, then addition. So we have three terms. Anytime we have something with three terms, it's called a trinomial. What we're going to practice doing here is we're going to practice multiplying these types of things together. Right? So what would happen if I take a monomial and I multiply it times another monomial? What's the result? Okay? Let's see. Did I go too fast? Should I leave that up there? I'll just work below this. Okay, first example. Let's say I have a monomial And I'm going to multiply, so I'll put times like this, another monomial. So somebody give me a monomial. I don't care what it is. Any monomial you can think of. What? 5x squared. Good. Okay. Let's multiply that times someone else give me a different monomial. 4y. That good? So I have a monomial 5x squared times another monomial 4y. Remember in last class when we added terms together, they had to be like terms. When you multiply monomials together, they don't have to be like at all. Okay, you can still multiply them. So the way that this is going to work is we're going to use the fact that 5x squared is actually 5 times x squared. That's what that means, right? Then I have times 4, and then isn't that times y? I mean, that's really what that means. It means 5 times x squared times 4 times y. So it's a bunch of multiplication. And whenever we have multiplication, we can always slide things around. Okay, move things left and right, and nothing changes. So what I mean is I can take the 5 and the 4 and put them next to each other, make that 5 times 4. And I can take the x squared and slide it right next to the y and have x squared y. Now what is 5 times 4? 20. So you get 20 from the number, and then x squared y, I cannot do anything to that. So I just put x squared y. And that's it, we're done. So if you look back up at the original problem, we probably could get from that answer to, from that to the answer straight away without really having to write all this, right? You could just go, okay, 5 times 4 is 20, and then x squared y is just x squared y. And that's what you'll be doing, but I just want to show you why it's working, because it's all multiplication. Questions? Try a different example. Again, I'm going to put mono. I'm just going to put mono because I'm lazy. Mono times mono. Mono e mono. How about this one? Negative 7x squared y. I put that in parentheses times negative 10 thirds xy cubed. Now something very subtle but important has happened here. I put parentheses around this, and I put parentheses around the second one, right? That separates the two monomials from each other, right? If I did not have those parentheses, would this be multiplication anymore? No, it would be me trying to take this term and subtract this term, which would not, we wouldn't be able to combine them, right? Why? These aren't like terms, are they? X squared y, I would have to have x squared y on the other one. I don't. So if it was subtraction, we actually could not do anything here. That's why me putting the parentheses around this, like this, is so important in the problem. It implies that we have multiplication right there in the middle. That's multiplication. Mult is what I put there. So let's get to multiplying things around here. We already know that this is negative 7 times x squared times y, and now times negative 10 thirds times x times y cubed. So I'm just going to kind of slide things around, put all the numbers together. I'm going to kind of group my x's together and my y's together. So I should have something like this. I'm trying to take negative 7, right? I'm trying to multiply it times what number? Negative 10 thirds. So I'll look at that as a negative number. Then I have an x squared, and I'm trying to multiply the x squared times what? X, right? And then I have a y, and I'm trying to multiply that y times what? Y cubed. Okay, so see how I just rearranged everything here? What do we do for the number in front there? Negative times negative should be positive, right? And negative 7, I could look at that as a fraction. I'm just going to put it in there. That's really negative 7 over 1. How do we multiply fractions? Straight across, top and bottom, right? So we should get what over what there? 70 over 3. And now let's use that property that I put up on the board earlier. I said recall. What's x squared times x? X to the third power, right? Because what's really up there on top of that x on the right? It's a 1, right? This is really a 1. So I'm going to add the powers, I get x cubed. And then on the y's, I do the same thing. Y to the what? 4th, because that's a 1 right there. So I get y to the 4th. And we are done. So you see with multiplication, you don't have to have the like terms to be able to do it. You just have to be able to combine numbers together with multiplication and then the variables using the exponent rule where you add the exponents. All right, now that's monomial times monomial. I've given you 2 examples. Let's try something different. Let's try a monomial times a binomial this time. Now, monomial has how many terms? 1. Binomial has how many terms? 2. So the way I'm going to have to write this is as follows. Let's say my monomial is negative 5a squared b. And I want to say times a binomial. So I just put a set of parentheses here. Inside there, I'm going to put a binomial. So how about 2a b to the third, b to the third minus 5a. Do you agree that that's a monomial times a binomial? You see the multiplication right there? I mean, the parentheses implies that's multiplication, but it's multiplication of that whole monomial times whatever's in here. With me? If that negative 5 was not there at the end, right? If that wasn't there, that would just be monomial, monomial. But it is there. So the way we do this is we use what we call the distributive property of multiplication over addition and subtraction. That's the technical word for it. But really all it means to us is that we're going to take that monomial, we're going to multiply it times that monomial, right? That by itself is a monomial, 2ab cubed. By itself is a monomial. So we're going to go the monomial on the outside times that monomial, and then we're going to do that monomial on the outside times that monomial. So it'll be 2 monomial multiplications. So those are the 2 that we're going to do. So let's do the red first. What would the red be? So I'll do the numbers first. Negative 5 times 2 is negative 10. Then let's do the a's. What's a squared times a? A to the third. And then what is b times b cubed? B to the fourth. Y'all comfortable with that? Yes, and that's what I'm about to do now. Okay? So it's 2 separate multiplications that we have to do. It's kind of like this. I don't know if this will help, but like if I gave you this, 3 times x plus 2, you know how we go 3 times x, 3 plus 2? It's kind of like that, but we're doing this monomial here and then this monomial here. So what will we get for the blue? Let's see. Negative 5 times negative 5 is multiplication, though. Positive 25. So plus 25. And then how many a's here? A cubed. Do we have any b's? We still just have that one b, so the b stays. Now, how many terms do we have right here? How many terms is this? 2 terms, right? And think about it, because we're going to keep extending on this. On the monomial, how many terms are in a monomial? 1. How many terms are in the binomial? 2. We multiply together. What's 1 times 2? 2. That means we should get 2 terms when we come out. Because the next thing that we're going to do is monomial times trinomial. So how many terms do you think we should get when we multiply out? 3. 1 times 3, we should get 3. Question. Next example. Mono times trino. We good? That's a monomial times a trinomial. What do you think we're going to do? Distribute, right? So we're going to start with that monomial in the front, and then it's basically going to, I like to say hit, even though it's just multiplication. That negative 3x squared is going to hit the x to the fourth. Then after that, the negative 3x squared is going to hit the negative 3x squared. And then the negative 3x squared on the outside is going to hit the positive 2. So 3 multiplications through. So let's do it. I'll do red. I'll do green. I'll do blue. So those are my 3 multiplications. The red multiplication through should give me negative 3x to the 6, because we're adding the exponents, right? 2 plus 4 is 6. The green should give me plus 9. Just remember you're multiplying, right? So negative 3 times negative 3 gives us positive 9. And then x squared is x to the fourth, adding, right? Exponents. And then finally, the blue, negatives, negative. That's negative and minus at the same time. 6x squared. So how many terms do we have in our final answer? 3. Now, something I didn't really point out that I'll point out now. You see our 3 terms? Are any of them like terms? Can you put any of these together? Not through addition and subtraction, right? They would have to have the same variable, same power. So I can't put these together. Also up there on the one we had before, we can't put those together because they're not like terms. I say that because in a couple of problems from now, we will actually do this, and then we'll notice, hey, some of those are like, and we'll put them together. Now, we've done monomial, 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 binomial, monomial, trinomial. So what do you think's next? Binomial, no, we're going to do binomial, binomial now. Okay? Yeah, so if we do binomial times binomial, we have 2 terms to start, right? Multiply by 2 terms. We should get 4 terms when we're done. They might collect together. You know, we might have like terms and we might have to collect them, but the initial multiplying through should give us 4 terms. So let me make up a binomial here. How about x? I'll try it with something you may be familiar with. X plus 7 times x minus 3. What was that? You all right? What did you say? You want to use 9 instead of what? 7? I'll do 9 on the next one, okay? Just for you. Okay, so do you agree in the first set of parentheses I have a binomial, in the second set of parentheses I have a binomial? Now, do you also agree I have to have parentheses? Right? Like if I don't have parentheses in here, that doesn't tell me I have binomial times binomial. You should be asking yourself, well, what the hell is going on between the 7 and the 4x? That looks weird, right? So we have to have the parentheses to help us separate the binomials. Now, what we've been doing, we've always had a monomial sitting on the outside, right? And we multiply it through, basically. That's what we've been doing. What I want you to do is just kind of squint your eyes and just forget that 7 is there. Would you agree that if that 7 wasn't there, this would be a monomial? And then you would just go to the 4x with it, and then you go to the negative 3 with it, right? That's exactly what we're going to do. We're going to act like the positive 7. We're going to act like the positive 7 is not there, and we're going to distribute just the x through. Okay, just hear me out here. Let's do this. So act like the 7's not there. Multiply x through to both of those. So what would we get if I do x times 4x? 4x squared. And then what's x times negative 3? Negative 3x, right? Now, we have not done anything with the 7 yet, right? So now what we're going to do, after we've done the x, right, we've kind of already passed that x through, we are now going to act like the x isn't there, since we've already used it, right? And we're going to act like the 7 is our monomial on the outside, and we're going to pass the 7 through now. Okay? I'd like to change a little bit of my color coding here. So I'm going to go back here, act like that went to there. Let's make blue go. Notice I'm going to put my loops on the bottom just to show you, just because I don't want to get it too cluttered on top. So I'm going to go, the 7's going to go through to the 4x. What's 7 times 4x? 28x. And then the last one, I'm going to multiply. I got all kinds of colors. I can go here to here. Light blue, okay? What's that? I did forget the x. What's the light blue one there? Negative 21? Let me come back and put that x back in. 28x. Do y'all see that? So we have 4 terms, don't we? 1, 2, 3, 4. However, look at the middle 2 terms. Those are like terms, aren't they? And because they're like terms, we can add them together. So the way we do like terms, addition, subtraction, is we say, okay, they both have the same variables, raised to the same power. So we look at the numbers in front, the coefficients, and we put the coefficients together. So what's negative 3 plus 28? 25. So my final answer will be 4x squared plus 25x minus 21. None of those are like, so I box it. Well, in the initial multiplication, you will. So when you first do the distribution, you will have 4 terms. From there, it might actually condense down further. Yes? Oh, here? It doesn't matter to me, but books will normally ask for what's called descending order, which means you go from the highest power of x down. It doesn't matter if they were mixed up. Like this would be a correct answer. That's the same thing. So it's not wrong. All right. You ready? Oh, I wanted to show you something. How many of you have ever seen this before? It's your favorite 4-letter F word. Wrong word, I guess, huh? Y'all seen that before? What am I writing? Foil? How many of you have seen that before? Foil. Everyone's like, foil. I can foil. Y'all seen that? What does foil stand for? Do you remember what it stands for? Foil is a cute acronym. An acronym is when you take something and you take the first letters of the words and then it makes up a word. So like the F here stands for first. The O here stands for outer. And then inner. And then last. I'll just do it in dark blue. First, outer, inner, last. And that's the way a lot of teachers teach how to do binomial times binomial. They say you take the first guy here, right? The first guy, and you multiply him times the first. So F in this first step, right, is you take the first and the first, multiply them together. We did that, didn't we? And then in FOIL it says now you do the outer ones. So the outer, when we say outer, we mean the outer like this. And that's the x times the negative 3, isn't it? But isn't that exactly what we just did? Yes? And then I for inner means you do the 2 inside ones, which are the 7 and the 4x. Isn't that what we did when I showed you the way I wanted you to do it? And then last is the last one here and the last one here, which is negative 21. Yes? Now, the reason why I don't teach FOIL is just because FOIL's great when you have binomial. But what happens if you have binomial trinomial? Then you use the other 4-letter F word, and that's what you are. You're just, because you can't do it. All right? Seriously, I mean, like the binomial, FOIL works for that. Other than that, it doesn't work. So I would rather teach you something that would work for try, by, try, anything than to show you a cute little thing for just one scenario. What's that? Yeah, we're going to do that now. The way I did it is exactly the way we'll do it. Okay? Any questions on this, though? Has anyone seen it done this way? This is just an alternative method, where what you do is you write out the first binomial horizontally, and then you write out the other binomial vertically. And you create a table. Has anyone ever seen something like that before? And so to multiply this binomial and this binomial together, you do, if you want to know what goes in this box, you do this column and this row. So what's x times 4? 4x squared. Then if you want to know what goes here, you do 7 and 4x. What's 7 and 4x? 28x. Then if you want to know what goes in this one, you go x and then negative 3. What's x times negative 3? Negative 3x. And then the last one here would be 7 and negative 3 is negative 21. Now, if you add all those together, you'll get 4x squared. Hey, we had 4x squared. You'll have, let's do this one, negative 3x. Hey, we had negative 3x. And then 28x. Hey, we had 28x. And then you have negative 21, negative 2. So it's the same thing. It's just a cute picture. And some people really prefer that. You do what you want. Okay? I'm moving on. So we just did by, right? Now let's do by try. How many terms should I get after the initial multiplication? 6, because I have a by, which is 2. I have a try, which is 3. 2 times 3 is 6. So when I do my initial multiplication, I should get 6 terms. All right, here we go. Let's have fun with this. This is, I'm kidding. Plus 9 minus 9x squared minus 9x plus 9. Is that by try? By try. Now, the first two, right, that's our binomial, and then these 1, 2, 3, we got try. Okay? Now, what I told you to do last time with the by was look at the first one and just act like that other one wasn't there and make it like a monomial, and then pass the monomial through, right? That's exactly what we'll do. And then after we do that, we'll act like the 2x isn't there, and we'll pass the positive 9 through. Okay, so let's go ahead and do that. I definitely will, I won't run out of colors, but I don't want to be going back and forth with colors. So let me do this first. I'll do my 2x through to my 3 terms here. So what's that first red one there? Negative 18 x to the third, right? Y'all agree with that? What's the blue one? Minus 18x squared. And the black one? Plus 18x. Is everyone comfortable with that? The 2x going through to each one. Okay, am I done? No, now I need to pass what through? The 9. So I'll do like this, 9, then 9 is going to go here, and then 9 is going to go here. So the first one there, the 9 times negative 9x squared is negative 18x squared. The blue one is 9 times negative 9x, that's negative 18x. Did I? Yeah, I don't. Woo! The other ones were right. 9, 9, 81. Thank you for paying attention. Do you? Or do you like 9? You do? I'll show you something about 9s that you probably didn't know in a second. Okay, what's the last one? Plus 81. All right, so there was our multiplication. We are done at this point, okay? Once you have, I'll use the word exhausted the entire binomial out here, you've gone through each one, you've passed each one through, you are done. You don't have to then worry about anything going on here, all right? We have a total of 6 terms, but some of them are alike. I only have one x cubed term, negative 18 x cubed, but x squared terms, I have 2 of them, right? And I can combine those together by putting negative 18 and negative 81 together. That's negative 99. Oh, now 99, right? Negative 99 x squared. And then what about our x terms? Again, we have 2 terms, don't we? This time it's not 9, sorry. It's negative 63 x and then plus 81. And that's it. Make sense? All right. The last thing that we could possibly be asked to do is to do a try and a try. So 3 and 3. So we should have how many terms when we do a try? 9 of them. Yeah. Yeah. I didn't put above this, so I'll put it to the side. Try, try. So who wants to tell me, and where's my sign-in sheet? I'll give, who's going to volunteer for a bonus today? I'm not even going to tell you what I'm asking. You going to volunteer? Okay, so can you just explain what you're going to multiply here? Okay, what are you going to do? Okay. Okay. Okay, good. Okay. And okay, that's it exactly. Very good. Y'all get that? That's the pattern here. It doesn't matter if this first thing out here had 8 terms and the other one had 20 terms. You would do the same thing. You would start with the first one, pass it through the other one. Second one, pass it through. Third one, pass it through. You just do that until you've exhausted the first one. Make sense? Okay. Here. Sign in, and I'll give you a bonus, but just sign in first. Okay, and then I'll pass this around now for everyone. Okay. There you go. All right, try this one. See if you can do it. I'll work through it silently while you try and do it on your own paper, and let's see if we get to the same answers. If you multiply it all out, try and collect your like terms together and see if you get what I got. If anyone gets an answer, let me know if you agree with that. Anyone agree with me? Yeah. Well, I don't. Which one? Go ahead. You don't agree? I'm okay. Did anyone get what I got? Okay. What I tried to do is after I did all the multiplications, I tried to like show what the like terms were by putting appropriate symbols next to them, like a little squiggly underneath this and squiggly under that meant they were like terms. I circled all the x squareds. I boxed the x's just so I could kind of distinguish them from one another. Who else needs to sign in? No one? While I have you all here and I remember this Friday, actually this Thursday evening, I'll be leaving to go to a conference that's in Austin. Unfortunately, I have to do a 2-day conference and right on 6th Street, and it kind of sucks for me, but anyway, so I won't be here on Friday. I don't think anyone in this class has ever come on Friday for my office hours, but I'm just letting you know now that if this Friday was going to be the first Friday you come to see me in my office hours, I will not be there this Friday, okay? All right, so what do y'all think of this? Of course, you know, the only way to get good at it is practice, right? Did anyone not get this, need some help on it? It hung up on anything? No? Okay. When you multiply, like adding the exponents, okay, just you got to be careful with it. Go ahead and let's jot down your homework. Whoa. I'll put that back up there if anyone needs it. Oh, there was still something I need to show you. I forgot. Okay, but jot this down anyway, and then I'll show you. This page 376, we haven't, this won't take long, but I'll show you. These problems come from the next section. It's, yeah, don't forget what's up there. It's this right here, and then the one below it. Yeah, I picked them by just looking at them in the book, and so I don't know. There might be a pattern there of every other odd. I don't know. Almost. Yeah, almost. Yeah, until up till 31. All right. Got it? No? Okay? No? We're good? Okay, here we go. Let's look at this for a second. See that problem there? Negative 4x plus 3 squared. When you look at that, the negative 4x plus 3, isn't that a binomial? Right? Negative 4x plus 3 is a binomial. Squaring something means, and I put it over here on the side, squaring something means multiplying it times itself, doesn't it? So if I say take this binomial and square it, I mean multiply it times itself right here like this. And then you would just do what we just did in class, right? You would just start with the negative 4x, you would pass it through, you do the 3, you pass it through, you get these 4 terms, you collect like terms in the middle, and then you get a final answer. The mistake that we see so much on tests is students will try and say, oh, I see a power, and then all that means is I need to square each of these. Like I just need to square negative 4x, and they go negative 4x times negative 4x is 16x squared. Then they say, okay, now I just square 3, and I get positive 9, so they put plus 9, and they put this as their answer without doing the appropriate expansion this way. Y'all see the difference between the two? In the correct answer, you've got this middle term, negative 24x. In this answer, you're missing that completely. Since this is the biggest mistake I see on problems like this, on a test, if you do this, you will get 0 points. All right, so it's not even like almost, you know, like partial credit. You get nothing because it's such a huge thing for you not to do that that I want you to pay attention to it, all right? So squaring a binomial means doing that. That okay? Those last 2 problems on your homework set are just like those. So just write them side by side and then do your little expansion. The problem set? The homework? Try. Oh, okay. Did you have a? Did you disagree with something? Okay. Yeah. There we go. And like I said, I was going to end class at 1:15 today. I'm sorry for some of you that walked in may not have caught that. So we will stop now. You have your homework assignment. And the 9 thing, I mean, I can show you some cool stuff with 9s, but maybe not today. All right? Have you ever noticed, so y'all can go, have you ever noticed, what? That if you look at like 9, okay, there's 9, right? What's the multiples of 9? 9, 18, right? 27, 36, what do you mean? Yes, they all, if you add these digits together, you get 9, right? That's one thing, but if you take anything like, let's say 1, 8, 9, 8, 8, oh, that's not as interesting. Okay. 9, 10, 8, 4, 22, 3. 18,943. Okay, this number. Is it divisible by 9? Well, the way to check is you take the numbers, if you add up the numbers, all of them. Okay, so that's 9, right? That's 18, right? That's 22 plus that is 25. Okay, if you add them all up, you get 25. If they add up, if these numbers add up to be a multiple of 9, it's divisible by 9. So these don't add up to be a multiple of 9, it's not divisible by 9. So like if I had changed this number right here to a 5, then if I add up all the digits, I get 27. So I can guarantee you this is divisible by 9. It's a weird property of 9s. Yeah. Yeah. So I'll show you something else next time. Have you ever, oh wait, I'm still recording. Have you ever seen